In late September 2024, train services on the East-West line were disrupted along a critical stretch between Jurong East and Buona Vista, effectively cutting one of Singapore's busiest rail corridors for several days. What began on the morning of the 25th of September as a technical fault near Clementi MRT station quickly developed into a much larger infrastructure incident. The affected train was withdrawn from passenger service as a precaution. During this withdrawal process, however, a mechanical failure resulted in physical damage to the track and related systems. The damage was not confined to a single location. Rail components, power supply equipment, and trackside infrastructure were affected over a significant distance, making it unsafe for regular train operations to continue on that section of the line. As a result, authorities suspended normal services between Jurong East and Buona Vista. Other parts of the East-West line continued to operate, but the direct west-to-city rail link was no longer available. For commuters, this meant the sudden loss of a high-capacity, high-frequency connection relied on daily by large numbers of residents traveling for work, school, and essential errands. The scale of the disruption became clear within hours. The East-West line is a core artery of the MRT network, carrying heavy passenger volumes throughout the day. When a disruption affects such a long stretch of track, its impact spreads quickly beyond the immediate area, influencing travel patterns across multiple lines and transport modes. Unlike shorter delays or signaling faults, this incident could not be resolved within a single peak period. By the end of the first day, transport authorities indicated that the issue was not routine. The physical nature of the damage meant that detailed inspections and extensive repairs were required before trains could safely return to service. This set expectations early that the disruption would last several days rather than hours. For residents who depend on this corridor, the focus shifted rapidly. The question was no longer simply what had gone wrong on the tracks, but how tens of thousands of commuters would move across the city the very next morning, and for the days that followed. Once regular train services were suspended between Jurong East and Buona Vista, transport authorities moved from incident response to large-scale crowd and movement management. By the second day of the disruption, it was clear that normal rail operations would not resume quickly, and contingency plans designed for prolonged service interruptions were fully in place. The most immediate and visible measure was the deployment of free bus bridging services linking stations along the affected corridor, including Jurong East, Clementi, Dover, and Buona Vista. These buses became the primary alternative for commuters who would normally rely on the East-West line for direct access to the city. Additional buses were added during peak hours as demand patterns became clearer, with double-deck buses used where possible to increase capacity. Within the MRT network, services continued on sections unaffected by the damage. Trains ran normally at both ends of the East-West line, with some stations functioning as temporary terminals. Shuttle train services were also introduced on shorter segments, once limited sections of track were cleared for controlled operations. This segmented approach allowed parts of the network to remain functional while isolating the damaged infrastructure. On the ground, the disruption translated into longer and more complex journeys. Trips that were usually direct now involved transfers between trains and buses, with travel times increasing significantly during morning and evening peaks. By the third day, congestion around stations such as Clementi and Dover had become more predictable. As commuters adjusted routines and staff refined queue management and boarding arrangements. Clear communication played a central role throughout this phase. Regular updates were issued through station announcements, official statements, and digital platforms, outlining which services were operating and where alternatives were available. Additional ground staff and traffic marshals were deployed to guide commuters, manage queues, and address confusion, particularly during the early days of the disruption. Authorities also implemented fare-related adjustments to reduce friction. Passengers who exited stations because of the suspension were not penalized, and staff assisted with manual fare processing where needed. Schools and employers were advised to exercise flexibility, recognizing that delays were unavoidable despite the presence of alternative transport options. As the days passed, operations gradually stabilized. Queuing systems became more orderly, signage clearer, and travel patterns more consistent. While frustration among commuters remained evident, the focus of the response stayed unchanged. Maintain safety, provide workable alternatives, and restore full rail services only when the damaged section could be certified safe for normal operation. As the disruption entered its later stages, attention shifted to a question raised repeatedly by commuters: why repairs were taking days rather than hours. Transport authorities explained that the length of the closure was driven by the type and spread of damage, not by delays in mobilization or decision-making. The incident involved physical impact to multiple parts of the rail system, while a train was being withdrawn from service after an earlier fault. A critical component detached and came into contact with the track, and as the train continued moving at low speed, the damage extended along the line. Rails, power supply equipment, and trackside systems were affected over a considerable distance, making it impossible to isolate the problem to a single point. Repair work, therefore, had to proceed in stages. Engineers first stabilized the affected area, removed damaged components, and inspected surrounding sections for hidden defects. Only after these checks could replacement work begin. Rail segments and power components require precise alignment, while point machines, and which guide trains between tracks, must be calibrated carefully. Each completed section then had to be tested before the next phase could continue. By the third and fourth days, repair progress was visible, but restrictions remained in place. Authorities assessed whether limited shuttle services could operate through the damaged stretch. However, running trains on tracks under repair would have restricted access for heavy equipment and increased safety risks. Operating even low-frequency services would have slowed work significantly. The decision was therefore made to prioritize uninterrupted repair activity over partial service restoration. For commuters, this technical choice translated into continued reliance on buses and indirect routes, even as visible work progressed. For engineers, it marked a turning point. Uninterrupted access allowed repairs, inspections, and test runs to be carried out more efficiently, reducing the risk of reopening the line only to encounter further faults. The incident also highlighted how tightly interconnected the rail system is. A mechanical failure on a single train escalated into infrastructure damage that affected multiple stations and a major commuter corridor. This interdependence explains why reopening the affected section could not happen in stages, and why authorities waited for full safety validation before resuming services. More broadly, the disruption drew attention to the challenges of maintaining aging infrastructure. The East-West Line is the MRT network's oldest corridor, with sections that have been operating for more than 3 decades. While renewal programs are ongoing, incidents like this show how older components can interact unpredictably with daily operational demands. By the time repairs neared completion, the focus shifted again, from fixing damaged infrastructure to ensuring that restored services could operate reliably under normal passenger loads. When full train services between Jurong East and Buona Vista were eventually restored, the conclusion of the disruption marked the end of one of the most significant MRT service interruptions in recent years. Normal operations resumed only after repairs were completed, safety validations carried out, and test runs conducted to confirm that trains could operate reliably along the affected stretch. Services were restored only once engineers were satisfied that risks had been addressed. Beyond the immediate inconvenience, the incident sharpened attention on rail resilience and long-term reliability. The East-West Line is a central corridor for residents in Western Singapore, linking dense housing estates, schools, and employment centers to the rest of the network. When this link was disrupted, alternatives existed, but none matched the capacity and speed of the MRT under normal conditions. Transport authorities indicated that findings from the investigation would inform future maintenance and inspection practices. This includes reviewing how mechanical issues are detected, how trains are withdrawn from service after faults, and how repair work is coordinated when physical damage occurs. Any adjustments, they emphasized, would be guided by engineering assessments rather than timelines or public pressure. For residents, the disruption also illustrated how large-scale service failures are managed in practice. The response followed a familiar pattern: isolate the affected section, deploy alternative transport, communicate regular updates, and prioritize safety over rapid restoration. For many commuters, the disruption will be remembered less for technical details than for altered routines, longer journeys, and the need to plan travel differently for several days. The event also underscored the importance of redundancy within the wider transport network. During the disruption, parallel rail lines and extensive bus services absorbed additional passenger demand, allowing the system to continue functioning despite reduced efficiency. Future rail projects are expected to provide additional options for the Western Corridor. but such changes take time to deliver. In summary, the Jurong East to Buona Vista disruption was not simply a temporary service breakdown. It functioned as a stress test for a mature rail system operating at high daily loads. The lasting takeaway lies in the process behind the response: early containment of risk, sustained repair work, and a cautious return to normal operations once safety could be assured.